In this lesson we're going to talk about straight lines, and mostly in straight lines there are three formulas. The first one is gradient intercept form, second one is the point intercept form, and the third one is the general form. So the gradient intercept form is the most simple formula, mostly in IB, and it's equal to y is equal to m times x plus c. You have to understand that m is the gradient, and to put it simply, gradient is the decline or the growth in your function. Meaning that if I do a function right here, then if you see it going up, that's the gradient. If you see it going down, that's also the gradient. To put it simply, you can also understand that the gradient is the amount of change in y in your function. If the gradient moves up very quickly in the short period of x, then you understand that the gradient is very small, very big. However, if the gradient doesn't move up at all and is a straight line, you can understand that m is 0. And as I said before, and if m moves up very quickly, m is a very large number. So you can also have to understand that if I draw a function sheet over here as well, that I draw, let's say, something like this. And you might be wondering, what is c? C is the y-intercept. And you can always get this from your graph. Sometimes it's given. It's always you can recognize c in your exams when there is given, for example, the exercise says that one of the points is 0 and something. Let me write 6 here, for example. So if your question has something like this, where the first point is 0, then you have to recognize that the point is obviously on the y-intercept, meaning that it is automatically the c, and you get one part of your question already solved. However, there is a formula to get the gradient as well. So the formula for the gradient is also given in the formula booklet, and it's the following: y2 minus y1 divided by x2 minus x1. This is also given in your formula booklet right here as well, under 2.1. And how this works is actually quite simple. In many cases, when you're dealing with your paper 1 or paper 2 questions, or I think this can even be on your paper 3 as well, then you're given something like this, and and you're given a line. And mostly in your questions you're given 2 points. For example, the first point P is, let's not use P as I used it before. The first point X is 6 and 5, and the second point, or in this case the first point, is, let's use Z, and it's minus 3 and minus 2. And then you can always find the gradient intercept, and you can just use the formula to do this. I always like to use y2 as the point that's given that's more on the right. So I always use y2 as you also read from the left. I want to really use y2 as something that I get more from the right. Therefore, y2 is 5 minus y1. And you have to always know that if you have a coordinate, the second one is the y value. And y1 is minus 2. And so in this case, x2 is 6. And you can always do minus x minus 1, and so it's minus 3. And you can always do this in your calculator. 5 minus minus 2 and 6 minus minus 3, and you get your answer to be 7 over 9. And if you have your problem that the answer is in a fraction, you can always go to mode and you go to decibels in your answers, and then you can do the same thing over again, and you can get that it's 0.778, and that's your M. That's one of the most simplest ways to get M, as it's usually given your 2 points. There's no problem. So covering parallel lines and perpendicular lines, covering parallel lines and perpendicular lines Covering parallel lines and perpendicular lines are also very important in IB, as I have done many previous exam questions, and this is something that is very common in all of them. So parallel lines, you mostly have to understand that if you have 2 lines, let's draw line 1 to be green and line 2 be red, and you're given that they are parallel. So you always have to understand that if line 1 is parallel, let me draw this in black, is parallel to line 2, then you always have to understand that this means that they are parallel. I think this is something very logical, but I think the most important is that you have to understand that their gradients are the exact same. Because as I talked before, the gradient is the amount that your function declines or grows. And if you have 2 functions that grow or decline at the same amount, that means that their gradient has to be the exact same. And this is something very important to always keep in mind, because your exam sometimes might try to trick you, and you always have to keep this in your memory. However, if they're parallel, you always have to know that their C's cannot be the same. So perpendicular lines are the exact opposite. I think many of you have already learned this. However, to go over it, I think it's a bit necessary as well. So if I have line 1 going like this, and line 2 is the exact perpendicular, and if you have 2 perpendicular lines, this means that their gradients, so M1 times M2 is always equal to -1. And this means that if you have the perpendicular line, and if you have the gradient of line 1, for instance, then you can always just multiply, and if you want to get the perpendicular of your gradient, then you can always simply do this. So if you have your gradient, you can simply put a minus in front and then put 1 over your gradient. Therefore, you can simply put this as it is. And this is like the gradient form, meaning that you can always use this. So the point-intercept form is also given in your formula booklet as well. It's this one is here. And you know this as y1 is equal to mx minus x1. This is one of the most easiest parts, I think, also. So it kind of makes sense, where y1 and x1 is just, basically, to put it, it's just not randomly, one selected coordinate of the function, and it's usually given in your function that a coordinate is c is equal to 6 and 8, and then you can always just plug in your x to be 6 and your 8 to be y, and you know what the gradient already is. This is something you have to calculate yourself. And why it's different from the first formula, the gradient intercept formula, is that we can see that sometimes, well, most cases you have the formula where y is equal to mx plus c. However, sometimes the c is not given, meaning that the point with a y-intercept is not given, and then you have to resort to this formula if the points are given, and you will get the real answer. You cannot never use the function given to estimate c. And then for last, general form is I think it's the most general, as you can say, ax plus by plus d is equal to 0. And here you have to understand that all numbers have to be full numbers. I think that's very important. And what that means is that when you have your general form, it cannot be 2/3 or x. You have to multiply then everything to get the fractions out, or the decimal places out as well. And sometimes you're also given that when you have, let's say you have a gradient intercept form, which is that y is equal to 0.5x plus 3, and it says that convert this into a general form, and therefore you have to simply convert this into something more like this. So the first step would always to be simply just okay, let's write this down here as well, is equal to 0.5x plus 3. So your first task would obviously to be to bring this to the other side, meaning that 0.5x minus y plus 3 would be equal to 0. And then you notice something weird, that there's 0.5, and I said not to have fractions or decimals in your general form, therefore you multiply everything by 2 and you get x minus 2y plus 6 is equal to 0. And yeah, that's about it. So I hope you understood everything, and if you have questions you can leave it in the comments. Thank you.